Hello there. We are going to talk about vectors today, dynamic arrays in a sense, but vectors in particular have a lot of really handy functions that help us solve quite a bit of problems. And in particular, vectors are very useful for you to know because many programming problems out there on the internet, like some of those we discussed back in lecture 12, require you to know how to use a vector. And we're going to cover that as our last topic of the semester. So let's first start with setting up a vector. We're going to initialize a vector with string values, then make a function that iterates through the vector and prints them all. And we'll do some stuff after that. But let's start out with the basics. So initialize a vector with string values. So I'm going to need two more libraries for that. I'm going to need vector for sure. And I don't need string, but it's good to include it anyway. Okay, so I got vector and string. I'm going to need to make a vector string. It's called my vector. And we'll give it, hello, how are you? Just so it has some strings in it. Okay, so I've initialized a vector. Create a function that iterates through the vector and prints each element. Well, we can do that very easily. So our function doesn't return anything, so it's a void. We'll call it print vector because that's what it does. It's going to take a string vector. We'll call it v, I suppose. You can call it whatever you want. And what we're going to do is for each string, which is a word in the vector, we'll just print that word. This is a lot cleaner, I think, than having to do, for I equals 0, I less than the size of the thing, I plus plus. It's much quicker to just go string, word, in, vector, print it out. Let's go, print it. Oh, I made a mistake. Probably I should call the function, huh? Print vector of my vec. Hello, how are you? All good. Okay. Last thing you have to do, use size and capacity to print the size and capacity of the vector after printing. This will be helpful for later. So, the size is v.size. Do I need brackets? I don't quite remember. We'll find out. The capacity is v.capacity. And these are going to give us two values that we'll learn about in a little bit. But for now, we're going to have size and capacity. Let's see what they look like. Capacity is 4 and size is 4 because I made a vector of size 4 and there's 4 things in it, so it makes perfect sense. These numbers are going to change as we do some of the later exercises, but for now, we got the first one all done. Okay, and let's move on. So, second exercise. Use pushback to add 2 new elements, then pop back to take away 3. Call the printing function and see what happens. Okay, well, that's actually not too hard. Let's start with use pushback to add 2 new elements to the vector. Sure. So my vec dot pushback, push underscore back, I think. I'm going to put some strings. I'm okay. Let's print that out. Just make sure it works. So, hello, are you? Capacity 4, size 4, capacity 4. Hello, how are you? I'm okay. Size 6, capacity 6. Seems all right. Now let's try doing, was it pop back? Yeah, pop back. So my vec dot pop back. We'll do that 3 times and then print the vector again. So we got hello, how are you? Size 4, capacity 4. Hello, how are you? I'm okay. Size 6, capacity 6. Hello, how are? Size 3, capacity 3. All right. Now, does that change if I remove any of these? Just kind of out of curiosity. It looks like it's it's basically mapping the size and capacity to the same thing for now, but I think that's something that we'll be able to change later on. However, for pushback and popback, it looks like size and capacity change to match exactly how many elements are in our array at the time. And yeah, I guess that's it. All right, next exercise. Okay. Complete the following. No odds. Given a vector int, increment each odd element in the vector. Okay, let's do that first. So it's called no odds. Given an integer vector, increment each odd element in it. All right. So we're gonna leave this out for now. And we don't have to return anything, so this should be a void. No odds. And it's taken a vector int, called v, and it's supposed to increment each odd element in the vector. So here we have to be careful, because if we try to use this kind of strategy, for int I in the vector I++, this is not really going to work, and I'll show you why in a bit. But first, let's actually get. Right now we have print vector, but print vector only works for strings. It's kind of annoying. So let's make this print string vector. Print string vector. And we'll have another one called print int vector, so that we can print integers. So int. In 1061, we'll learn how to do this in a single function. But for now, we're just going to have our print integer vector. And we'll call that down here. But also we need to make a vector we can try this out with. So vector int, my int vec is, just put in some numbers. Seems fine. So some of these are odd, some of these are even. And so what this is supposed to do is supposed to increment all the odd ones. Increment all the increment all the odd ones so that they all become even, so there's no odd ones left. But let's see what happens if I try this. So first I'll print out my int vector to show what it looks like. Then I'll run no odds on my int vec, see if it works. I will print it out again. Let's see what happens. Okay. Run. So 7378945, size 6, capacity 6. Nothing seems to have happened. So the reason nothing happens is because in this loop here, when I take each integer I from the vector, I'm making a copy of it. And the copy of it, even if I change it, no one really cares. It's a copy. The vector itself hasn't been modified. So here I actually do have to use our typical I equals 0. I is less than, in this case, we're looking at v dot size, the number of elements that are in our vector, I++. And we want to take v of, and we can do v at I++. Let's try this again. Maybe I did that wrong. V I. Oh no, this sorry, it increments everything, right? Because I didn't tell it to or no, it didn't increment anything at all. I think that's because I need to perhaps pass this as a reference. Let's see if that works. Right now, I also haven't actually checked if they're odd numbers, but I want to make sure it actually can increment things, because otherwise that's kind of not right. Oh no, sorry. V at I. Okay, there we go. Now it's incrementing everything, but I only want it to increment odd numbers. So if v at I is odd, then do this. And there we go. Now we have all even numbers in our array. So let me backtrack just so I think through this a little bit quickly. We have our integer vector. It's got 7, 3, 78, 9, 4, 5. Our function no odds is supposed to take this and make it so every odd number in here becomes an even number, and that way there's no odds. So 7 should become 8, 3 should become 4, 78 is already even, so nothing happens. 9 should become 10, and 5 should become 6, and the 4 stays the same. When I print it out, see that the size and the capacity are 6, and it prints all the numbers out. When I run no odds, what it should do is go through each element. I use size here because size indicates how many elements are in my vector. If the elements at the index I is odd, then I'll increment it. Now I'm using v.at I But it's perfectly valid to also just use what we're used to, which is the standard index referencing with v of I in the square brackets, and this will do the exact same thing. Nothing will change. So totally fine. The reason you might want to use .at instead of with the square brackets is because just like with arrays, the square brackets will let you try to access things outside of memory. So if you try to access an index that goes beyond the range that your array actually, or your vector actually can fit, this can modify stuff it's not supposed to modify. By using .at, it will prompt you to double check, hey, are you sure that this is the index you want to check? Because if it's out of bounds, it will warn you instead of just letting you go ahead, which is a bit of a safety feature. So either of them is both correct in a sense. This one's just a little more safe if you're worried about making mistakes, so this might be easier for you to debug, but this one works perfectly fine and is probably the one you're more used to. Okay, so that was no odds. Then we have expand. So given a vector and an int n greater than the vector's size, expand the vector to size n and fill the new elements with the same value as the front. So let's take this one step at a time. It's called expand. It doesn't seem to return anything, and it takes a vector. I guess it didn't specify what the type is, so I think we'll go with an int vector just to keep it consistent. Sure. Okay. So expand given an int vector. Vector int. Oh yeah, one more thing I forgot to mention. You have to pass this as reference when you're making changes to, in this case, our variable v or vector. If you don't pass it by reference, any modifications that happen in here don't show up. So if I actually pause for a moment here, and I rerun this but without the ampersand, well, look what we noticed is all the numbers didn't change. And why is that? Well, that's because when I run no odds with my int vec, it makes a copy of this vector and throws it over here. Any modifications I make to the vector in here only modify the vector inside of no odds. So doing all this incrementing doesn't actually affect the vector that's over here, which is the reason that we use pass by reference. Same thing with other variables. So you need to use the ampersand to indicate pass by reference so that when you make changes over here, in this case we change each odd element to increment it, we want to make sure that gets tracked. Now same thing goes for expand. Expand here, we want to expand our vector. If we don't pass it by reference, we're expanding a copy of the vector, and that's going to get removed as soon as we leave the function. Not too helpful. So with expand, we need also an integer n which is greater than the size. So int n. And we'll assume by default that n is a big enough number that it's bigger than whatever the size is of our vector. So let's say maybe we'll be calling this with expand. Oh, sorry, it should be lowercase e. Yeah, it should be a lowercase e. Expand with my int vec, and let's say 10. So definitely bigger than how many things are in here. This will resize expand it up to size n and fill all the new elements with the same value as the front. It turns out we actually have a function from the previous slide that helps us do this very well, which is called resize, and also there's one called front, which is also quite useful. So resize changes the size to n. If n is bigger than the current size, the new elements are equal to x with a default of 0. So let's use resize. So v.resize. And in here, our parameters are n, which is what we're resizing it to, and we also need, according to the exercise, it asks us to fill the new elements with the same value as the front. So the front here is going to be v.front. That actually should be it. So let's see if that works. We'll print out our vector to make sure that it did. Let's actually add some just some wording here to space things out a little bit. So cout original vector make a new line. We have after no odds. Let's put that down actually here. And then we have after expand. let me close this a little bit, because we don't really need that. And let's see what happens. Oh, I made an error. What did I make? No matching call to resize. Well, perhaps I have the resize documentation wrong. Well, let's double check. You know, vector resize. This is the one. Resize takes n, and it takes a resize, so it has n elements. If n is smaller, it gets reduced, and is bigger, it gets expanded, which is what we want. If the value is specified, they're copies of value. Okay, well that seems to be right. And then you were mad about v dot from. Well, what if we do v0? Is that also okay? Oh, maybe I meant to do I was supposed to do parentheses here. Perhaps that was my mistake. Yes, I forgot my parentheses. That's my mistake. Okay, let's see what happens. So original vector 7, 3, 78, 9, 4, 5. After no odds, we change all the odd numbers into one higher, so they're all even. Now note that the first element is 8. After we expand, we add a bunch of extra 8s to fill up the space. So hooray, everything seems to be going quite smoothly. We'll wrap up with one more exercise before we are done. Okay, last exercise, or I guess pair of exercises, because there's two of them we have to do. First, only nums. Given a vector string, return a new vector that only contains the strings with a number in them. Okay. So we're going to probably need some help from the string library for that one, but that's okay. Only nums takes a vector string and returns a vector string. So we're going to need to keep all that in mind. Okay. So we're going to have only nums. It's going to return a vector string, and it's going to take a vector string. We'll call it v. We don't plan on changing v, so in this case it's actually fine to not pass it as a reference. You can if you want, but it doesn't make a difference really. Okay, now we want to, make sure we write everything correctly. We want to go through each string in our vector and put it in a new vector we'll return, which will only have the strings with numbers in them. So first let's make a vector we're going to return. This is called nums. It's going to be empty at first. And then for each word in our vector, if has number word, then nums dot push back word. Okay, now the problem is has number is something I just made up. It doesn't really exist. So our first thing that we can do is we can see if the string library has something for us. I don't think it will, but never hurts to check. String library. String class. Where are methods for our string class? We have ways to access the elements. We have modifiers. We have operations. We can do searching. I guess what we probably want to do is we can go and we can search to see if each number is inside of our string. So we probably want something like find for that, I think would be good. So find here searches for the first occurrence. And well, what does it return? If no matches were found, the function returns string and pause, which I think is the end of string character. Well, that's not really what I want. Find character and string. I definitely want that. Just trying to see if I can find exactly the string function I want. I mean, I could do it manually, which I guess is fine. Sure, you know what? When in doubt, you can always just, if you don't want to have to worry about figuring out documentation, you always just write the function yourself, you know? We'll do it live. Okay. So, has number is going to give us true or false. So this is a Boolean function. It's called has number. It takes a string word. It's going to return true if it has number and false if it doesn't. So if it doesn't, return false. We're going to hope that it returns true. So, okay. Now, here is where we need word.size, because we need to know how long the word is. But for it's I is 0, I is less than the, sorry, not size, length. It is length, right? I think it's length. Length and size seem to do the same thing. And I imagine this is, yeah, with the parentheses. Okay. Always good to, double check your work. Okay. Word.length, I++. So we're going to iterate through each character. And now, as we iterate through each character, we also want to iterate through the numbers 0 to 9 to see if there's a number in there. So for int digit equals 0, digit less than 10, digit plus plus, if word I equals digit, and we need to cast this as a character. I think there is a function for that, perhaps? Oh, maybe not. Okay, before I move on, I should double check that this will do exactly what I want it to do. What? So my issue is I want to iterate through 0 to 9, and I want to check to see if the character there is the same as the digit there. But then when you compare an integer and a character, you have like kind of the issue with ASCII. So is there a way that I can convert? I mean, I could do it one way where I convert the integers into their ASCII values, like what's the ASCII value for 0 and so on. Yeah, that's one way to do it. But let's see what happens. So what if I do character of 6? Is that going to give me a... Or let's do it the other way. Let's suppose I do int of G. Is going to give me the ASCII value, I think, right? Why are you angry? Oh, I have to put has number above the function I call it in. Always a good thing to make sure that you're careful about is either you have to position all your functions in the right order, or you have to declare all your functions at the top, which is something we'll get in the habit of doing next semester, so that when you try to call them here, they've already been defined up here. Okay, simple error. Yeah, okay, 103. So here's what we're going to do to figure out if something has a number. What is the integer value of 0? So the integer value of 0 is 48. So what we're actually going to do is we're going to go from digit equals 48 less than 58, because I imagine that 9 is going to be 57, right? Okay, cool. So from 48 to 58, if the integer representation of the character is equal to the digit, we'll wrap that in parentheses, that means we have found a digit in our word and we can just immediately return true. Okay, this is a weird looking function. We have to go through every character. For every character, we have to go through the digits 0 to 9, and if they match at any point, we return true. This is just to check if a single word has a number in it. If there are no numbers in it, we've gone through everything, we say false. Let's do some tests. Anytime that you've written your own function, you should always test it so you know exactly what's happening. So let's output, so this is our testing has number. And we'll output the result of has number on a few different strings. So let's try let's try none. We'll try like 5 of them. We'll have none with a 0. We'll have none with a number at the end. We'll have something that's just a number. And we'll have an empty string. This should return false as well. So let's see what we get. Oh, should put a end line after them so that they are separated. That's a good idea. Okay, we get 0, 1, 1, 1, 0. So none, yes, 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 none. Okay, so our has number is good. We don't need these tests anymore. We're pretty happy with our has number, which means if our has number works, then our only nums will correctly identify if something has a number, and then we'll add it to the vector, which we will then return nums. So now we need to make sure our vector only nums works. So what we can do is we'll make a new string vector. Sure, we'll do it down here. Vector string, my string vector, my string vec is, let's give it some strings. Hello, how with a 0, are you 1? And if we did our what is it, only nums correctly, then we should be able to do vector string nums equals only nums from my string vector. And then we'll try to output only nums. All right, output the nums. And this is a string vector, not an integer vector. Okay, so let's pause a bit just to see what's going on here. We suppose we can ignore this for now. We're working with something different. Just comment it out. Lots of comments in there. Maybe I'll come back to them. My string vector has hello, how are you, and how is a 0, and you is a 1. Nums is going to be me trying to call the function I just wrote using this vector, which should only return a vector that has the strings that have numbers in them, so how and you. After I run that, let's see if it prints out how you. How you, look at that. And the size is 2, the capacity is 2, because nums only has 2 elements. Hooray. Okay, one more. del3, given a vector, I guess once again we should give it a type. Let's say, we'll do int, I think. Oh, the formatting is brutal. With we'll do a string one as well. Sure. Okay. Given a string vector, return a new vector with the same elements excluding the first 3. Okay. So del3 is going to be a vector string del3. It's going to take a vector string v. I don't think we plan on changing it, but again, it doesn't really matter, as long as we don't. And now what this is going to do is going to return to us a new vector, so we should make a new vector. String new vec. And what we'll do is, there's a couple ways we can do this. I think the way we'll do it is using a for loop, because I feel like that makes the most sense. So for int I equals, now I'm going to pause for a sec. We're not going to do 0 actually. We're not including elements 0, 1, or 2. So those are the first 3. We're actually going to start at 3. Then I less than the vector size, I plus plus. And here we will do new vec dot pushback v of I, and we'll return new vec. All right, so if this works, it'll make a new vector. It'll take all the vectors from v except for the first 3, and it'll push them all one at a time into our new vector so we can return it. Let's see if this works. So we already have one vector here. Let's ignore our only nums for now. So if we do this correctly, then when we try to make this work, it should give us an array that only has u and nothing else. So let's give it a shot. del3, so vector string 3 less equals del3 of my string vec, and we'll print it out. So after del 3, let's print out 3 less. Let's see what we get. And that's it. That's it. Hooray. So we've written a lot of functions. Some good lessons to take away from this are it's always a good idea to test your functions to make sure they work. Our has number, we can only be confident that is functional because we tested out with several different cases. We're happy it works. This is a little bit messy way to do this. 48 and 58 just seem to kind of come out of nowhere. This is the kind of thing where you definitely would want to comment to say 48 is the ASCII value of 0, 57 is the ASCII value of 9. Just so someone who looks at this code isn't like, what on earth is going on here? Because even if you pass this to somebody who is like an expert in computer science, very often they'll be like, what the heck is 48? Where did this come from? A lot of the rest of this code doesn't need too much commenting, to be perfectly honest. I've noticed that students seem to be putting in a lot of comments where they don't need to be there. This is the kind of thing that deserves a comment, because anybody looking at this, even if they understand how the code works, is going to be very confused why the numbers 48 and 58 come here, and we only know because we went through the process of figuring it out. So this is the perfect place that you should have a comment. But like other things, like you wouldn't really need a comment for this. It's just one line of code. We also didn't really get to see a chance for size and capacity to be different. This is a thing that can happen, but I think didn't happen to us mostly because we always were using pushback and popback to keep track of the size of everything. We never really modified the array in any other, or the vector in any other way. I think perhaps next lecture we might see some cases where size and capacity are different, but for now, it seems like they're, we'll keep checking both of them, but you generally should try to use size because capacity actually does mean something different. But that's all for today. Thanks for watching, and I'll see you in our the next video. Take care.